Hi guys, welcome to the session. This is the Oracle Machine Learning Office Hours. This is our first office hours of 2022. My name is Marco Serancibia, and today we're going to have a session on the Oracle Machine Learning Feature Highlight, the new OML Notebook templates for machine learning clustering. And with me, we're going to have Shari LaMonica as well. She's going to be presenting a specific new feature for the Oracle Data Miner, which is the connectivity to Autonomous Database. Joining us also is Mark Hornig, so if you guys have any questions at any time, please don't hesitate to put them in the Q&A, and we'll be more than glad to help you guys out with it. So for today's session, then, we're going to talk about the upcoming sessions. Then Sherry is going to talk about the Oracle Data Miner UI, and I'll go into the follow-along OML Notebooks ML Clustering demo session, and then we're going to finish up with the Q&A. So today's session, we're going to be focusing on the clustering side. We already did the classification and regression. So if you guys need to watch the recordings, they are available. And the next session are going to be the feature extraction for dimensionality reduction, and then a feature extraction for explicit semantic analysis. And then we're going to finish up with the time series analysis one. So you can see that the next session after today, we have January 18 on the OML Notebook templates for feature extraction. And we have on February 10 a hands-on lab, Introduction to Oracle Machine Learning for Python on Autonomous Database. And there's a special version of that same training on February 11th, and that's going to be in Portuguese. Those are the next sessions. So now Sherry is going to talk about the Oracle Data Miner for Autonomous Database, how to set up the Oracle Data Miner repository, so that you can use it to connect it to Autonomous. And thank you very much, Sherry, for joining.
Thank you, Marcos. Hello, everyone. So Oracle Data Miner is now available for Autonomous Database with the release of SQL Developer version 21.4, and I'm going to show you how to get up and running with it quickly. If you download SQL Developer and unzip it on your client system, Oracle Data Miner comes as an extension to that, so it's already there. And if you're not already familiar with Oracle Data Miner, it's a drag and drop, code-free machine learning environment that automates your machine learning workflow. So it has steps for data preparation, model building, and model evaluation, and it supports machine learning algorithms for regression, classification, anomaly detection, association, and feature selection. The machine learning algorithms are part of the Oracle Machine Learning in Database algorithms. They work on your database tables and views, and they leverage the database to maximize your workload scalability and performance. So connecting to Autonomous Database. Establishing the connection from your client machine requires a cloud wallet. If you have administrative access, you can download the Oracle Wallet from the Autonomous Database interface directly, or if not, you need to contact your administrator for help. And in the database connection on the right, we're connecting as the admin user with the connection type Cloud Wallet. The admin user is required because you need to install the Data Miner repository as admin. And an important thing to note is that I'm connecting with the service level low. The low service level will run your SQL queries serially in Autonomous Database or non-parallel, which is what you want when you're installing the Data Miner repository. So let's take a look at the installation. For the installation, you want to use the install ODMr SQL script. And you'll pass two arguments, data, the default user table space, and temp, which is the default temporary table space. You can use the double @ symbol to run the script directly from the SQL Developer home scripts directory, or a single @ and specify the full path to the script as you see here. You won't use the wizard in the Data Miner connection from SQL Developer. This works for Oracle Database on-premises only because it requires access to the SIS account. The Autonomous Database does not have direct access to the SIS account. The administrator account there is called admin, and that's used to configure and modify users. Once you have the data miner repository installed, you'll apply the required grants to an existing database user, or you'll create a new user and apply the required grants to the new user. For an existing user, you'll run the SQL script user grants as admin, and the user will be granted access to all the objects it needs through the ODMr user role. And it's that simple. That's how we configure the existing database user. So let's look at creating a new user in the next slide. To create and configure a new user, you'll use the script create user, the SQL script create user, again as admin. You'll pass a new username and the password for that user as arguments to that script. And again, if you don't have admin access, your administrator will need to do this before you can use Oracle Data Miner. And that's it. It's very straightforward and simple. Let's look at some links on the next slide to help you get further. Oracle Data Miner, the Oracle Data Miner site on oracle.com has all of the links to documentation and tutorials. The Oracle Machine Learning GitHub is where we have data miner workflows that you can run on your own. And the blog listed here has all of the information I covered today in more detail to help get you up and running. And don't forget to check our Ask Tom office hours session schedule for future sessions on Oracle Data Miner as well. And that's it. Back to Marcos.
Excellent. Thank you very much, Sherry. Yeah, we already got a few comments and people asking how to install it. So I replied to the Q&A. So you can use, if you don't want to use SQL Developer Desktop to install it, right? You can definitely use the SQL Developer Web, but you would need to get the files, right? The installation files from a desktop version, right? Sherry, I believe. I'm not sure now because there are many interconnected scripts.
Yeah, there have
right?
scripts that call other scripts. You would have to upload that entire directory to your autonomous database and have a directory where you could call them.
Right.
Yeah.
All right. Excellent. Thank you very much, Sherry.
Thank you. Thank you.
So now we jump to the OML Notebook templates for clustering, right? So if you guys missed the previous versions, please, you can check out the recordings, right? So we have already done that for classification and for regression. So today we're going to go in the clustering side, right? So for clustering, we got 5 different scripts there. So for Oracle Machine Learning for Python, we have the expectation maximization, the k-means, and then for SQL, right? OML for SQL, you have expectation maximization, you have k-means, and you have the O cluster, right? So the only difference you're going to notice here is that we don't have an interface to O cluster from the Oracle Machine Learning for Python itself, right? So that's why we have these number 5, right? Five different ones. So as before, you know, if you guys have access to any Oracle Machine Learning, always free, any of those, you're going to see this kinds of things, right? You're going to see there is a template examples, right, in the quick actions menu, and also the examples when you open up the hamburger menu, right? Once you get there, then the idea is that you would just type class, right, in the search filter, and that will show you the 5 ones that we have. And then we're going to click on one, right? So we're going to click on the lib, not exactly on the name. Remember that if you click on the name that shows up like a link, you're always going to open up only the original one that we built as read-only, right? So it is interesting if you want to pick into the code, but it's not going to help you write your own code or play with it, right? So we're going to click on one of those, and then we're going to basically click on the button on top, create notebook, right? So once that it's blue, we're going to click on create notebook, and then we're going to give it a name, and we're going to say okay, and then it's going to show up in our list of notebooks, right? So so let's do that then. So I'm here in my Oracle Machine Learning, and then again I'm going to click on that hamburger menu, for example, and come down to templates examples, right? So I'm clicking on examples, it's going to show me all the examples, right? They are available. So if you scroll down here, you're going to end up seeing that there are several pages. There are 75 different items, right? So we want to filter this thing. So we're going to click on here and say plus, and now we're down to the examples about clustering. So we're going to just select one of these guys. So I'm going to click on the k-means clustering on the Oracle Machine Learning for Python as an initial one, and then click on Create Notebook, right? So when you guys do that, you can just give it any name, right? By default, it gets this parenthesis 1 naming there, but we can just say, k-means sample. You can put a comment on it, right? From template, right? You can just put a comment for your own sake later on, right? That you might remember. And this is the project that I'm going to put it on, right? So when you say OK, you're going to notice that on the top right, you get a confirmation, right? That this notebook has been created in your project, right? So now if I go here and click on notebooks, I'm going to see that sample there, right? So the idea then is I'm going to explore that sample, so I can click on it. And basically, that's going to start up a notebook server with that notebook template for me, right? Now, remember that the first thing we need to do once the notebook is loaded is that we need to check on the interpreters, right? So remember that all the way to the right here on that little gear here, on the black gear, we want to click on that because we want to make sure that this guy is turned on, okay? So you're going to make sure that the medium here is checked, right? At least the medium is checked. You can check on low. It depends on what you're doing, right? I like to use medium, but because it gives me some parallelism, but it doesn't take over the entire machine when it's running. You can do high or low, right, if you prefer. But so in my case, I want to make sure that this is highlighted and click on save. And remember that we want to run them, right? This is because this was run by our users, right? Our test users, and this was back in August, right? So you want to make sure that everything is working and your tenancy, that you have everything okay. So you can just click run all paragraphs and confirm and say okay. Okay. So this way you get a brand new, a fresh execution, and with that, when this is fresh, you can actually make changes, you can explore things, you can see the variables. So it makes it easier for you, right? So if you scroll down, basically what we're doing here is we're importing the libraries. So we're basically setting up the libraries here. We're going to then prepare the data. So all we're doing is basically using a query to join two different tables, right? So we have data coming from SH customers, right? The SH schema customers. And then we have, so that's the customers data. And then we have a demo coming from supplementary demographics, right? So you can avoid using the query and just say table equals and then get the entire SH supplementary demographics. But this is a nice way to filter out some of the columns, right? So you're choosing a few columns from that table. So that is available as well, right? Now remember to be careful with all of the quotes, double quotes, and triple quotes, like in this one, in this cases here. So with that, we're joining the two tables, right? We're just saying merge. So I'm going to get the table customers, and I'm going to join it to the table demographics, right? And then we got the data over here. So I can see customer ID, gender, marital status, year of birth, income levels, credit limits, education, and all that, right? Affinity card, occupation, and stuff like that. So we're going to build a k-means model, right? Using the customer, the new customer DF table, right? The proxy object that we created. Now, for that, if you want to use the default, right, like this, you're going to see that as a we are basically saying I only want 20 iterations. I want to use 7 as my random seed, so just that I can make sure that I can come back to the same exact clustering, right? When you add the seed there, you can keep that consistent, right? So the next time a colleague of mine run this, he's not going to get different results. He's going to get the same results that I got, right? So it's a good practice to keep a random seed there. But in this case, notice that I'm actually telling it number of clusters equals 3 here, right? And that's important because the k-means clustering methods, right, are expecting you to basically tell it a number, right, of clusters. So usually what you're going to have is that the number of clusters is here. So you got to be careful that, not to think that it's over here, right, in the settings, but it's directly in the call. So you're calling OML KM, and this is where you're going to put that number of clusters, okay? So that might be a little different than the other methods that we saw for regression or classification, where we were specifying all of the options in the settings side, right? So once we do that, then we created that object with the settings, and then we do a fit. So we pass that, we give it a model name, which we dropped before, and we pass a case ID, right? So that is building the clustering model, right, in a very simple way. Now, on the right-hand side, you have the same kind of process, but without the defaults, right? That means we wanted to change the defaults for many of the different options. And in here is just because we wanted to show you guys that we have a lot of options here, okay? So in this case, you have, convergence tolerance, you have distance, right? So you can change the distance type, a minimum % of attributes for support, number of bins for a split criterion, keeping the random seed there, the details, right, of all of the k-means, and then ODMs details for the details of the prediction details, right, that you get for every customer, of the reason why they were assigned that cluster, right? And then even the sampling, right? So I'm disabling sampling. So I'm saying just go and do everything, right? Do all the entire data set. And then, so the same thing again. So an automatic data preparation on, which is a default, but we're just showing you here some options, right? So when we do that, then basically the details are down here, right? So after you run that, then this is what you get, right? So the cluster, the model name, right? That's the cluster model. The owner is you, the algorithm that was used, and then you get all of the settings, right? The settings that were determined by either a default, so something you might have not assigned here, or something assigned by default. If you didn't say anything about it, we're gonna get a default, right? In this case, a missing value treatment, for example, right, is something that by default it was created for you, right? So I have a model that converged. These are the attributes that were used, and these are the final clusters, right? So I have the counts here, right? How many records are in each of these clusters, right? And if you remember from a little bit of our cluster 101 that we did last year, the k-means in particular tries to do some equidistance distributions, right? So between the clusters. So we're going to go into more details again this year. We're going to go back to the 101 sessions where we're going to get more details to you guys as well. And we're going to share those original scripts that were created before, right? And then we get, the parent cluster was the child cluster, the centroids, right? So that's the information basically that tells you what are you expecting about that cluster, right? So it's telling me, in average, right, 23%, right, 23.8% of the people of cluster 1 actually has accepted, right, an offer for that affinity card in the past, versus from cluster 2, I have 33.2%, right? And that is because this number, the affinity card, is 0, 1, right? So it's just telling you, because it's a number between 0 and 1, or sorry, a 0 or 1, right? it's a binary option there. Then when you take the average, right, of everyone, then that gives you the proportion of ones, right? So this is 23, this is 33, and things along those lines, right? This is the average credit limit, right, for customers on that segment, that the customers on this segment, and things along those lines. Again, that helps you visualize or have an idea of what the clusters have in them, right? Same thing with customer gender. So it's telling you here, this is the mode, right? So the mode is the most frequent value. And at that point, it's telling you, okay, there's more males here, right? Cluster 2 also has more males. What we're looking at is now a little bit of that proportion for every cluster, right? That was basically created here. So remember that also it's telling you that what are the leaf clusters, right? When you're thinking about clusters, the leaf clusters are cluster number 3, cluster 4, and cluster 5, right? So these are the final clusters, let's say, right? The other clusters here are part of that grouping that I was mentioning before, right? The hierarchical information here. So then, basically that's basically what that's showing you, and then at the end it's showing you all of the probabilities and the proportions, and this is basically an associations, right? What it's showing you, if you have these, you have that. If you have these kind of things and that kind of thing, there's very likely that you belong to that cluster. So it creates rules for you, right? So at the end of the day, we want to check things like settings, right, out of that cluster. So again, those are the settings that we requested. And then we can check the specific clusters themselves, right? So cluster ID, so if it doesn't have a parent, right? If it has a parent level, that's the level, then this is the level, the bottom level of that leaf cluster, right, that we were talking about before. And then it shows you just the row counts, right? So something that is more interesting than that usually is to run the prediction and then get a plot. So this is not going to be a perfect plot, and remember, because we're using many more variables. We're using many more attributes, right, than the 2 dimensions here, right? But this is just to show you, in terms of customer year of birth and years of residence, right, how does this look like? So it gives you an idea of dispersion, and it gives you an idea of concentration of, the cluster number 3 here on top, and clusters 5 and 4 look like they are confounded a little bit. So there's definitely a confounding element here that's probably a different attribute, right? So we would need different attributes to actually be able to separate those others, right? So we're going to see more of that in the 101 machine learning clustering later this year. That shows you a little more in-depth capabilities, and we had some 3D plots that we used the last time, so we're working on that. And finally, what people normally do is really, okay, it's interesting to have clusters, but what do you do with them, right? So at the end of the day, what you want to do is you want to be able to compare distributions, right? So I want to know, okay, these clusters are clusters of similar people, right, on both sides. Right, so one cluster have a group of people, another cluster have another group of people, but why are they different, right? Why would the algorithm understand that these are different or separate groups of people? So an example here is, you can see the year of birth, right? So cluster number 4, for example, here has a bunch of people here in the late 60s, right? But it goes all the way down to the 30s here, versus cluster number 5, where you see there's a bunch of people here in the 60s, but there's an actual large group here, a jump in the 70s as well, right? So that's basically where I come from here. So, and then you don't have all the way down to, the 1920s or whatever, right? That this one shows up. So you start looking at these distributions and start thinking about, okay, how can I appeal now to those groups of people, right? In terms of marketing, in terms of strategy, right? And all of that. So finally, we have a SQL access, right? Prediction details. So you can actually use SQL to bring in the prediction details, and that basically shows you the following. So you can see, okay, now I know customer ID 100456 belongs to cluster 5 with these probabilities. So there's a % probability there that he belonged to this cluster. So this was larger than the probabilities of belonging to other clusters. But then these are the reasons why the customer belongs to that cluster. So those are that's a great information for you when you're looking into a specific cluster or specific customer, and you want to know why he was, chosen to belong to that cluster, right? So same thing as last time. I'm just going to quickly show one of the other examples that we have without copying it to my environment, which is, we can jump into one of the SQL ones, right? So OML4 clustering EM. Because I clicked on the name, I'm going to open it up read only, right? So you're going to see that you cannot even change the interpreter. You click on interpreter, you're going to get that information. Okay, you can't change it, right? Because it's a read only environment. But coming back here, basically that's what we're doing. We're doing this time is an expectation maximization algorithm. In PL SQL, you're saying the clustering name, what you're selecting in terms of the input, and then you have all the explanations about the overrides. So these are the options, right? Expectation maximization settings for learning, for cluster statistics, for data preparation. So you can see that basically that's what we're doing here. On the left, we're building the algorithm. On the right, we're showing you information about that algorithm, and then displaying the settings and things along those lines, right? And finally, showing the cluster details and details for cluster 9 and the histogram of that, and comparing that to a different cluster, right? So basically that's the idea. And finally, the rule details, right, for the leaf clusters, and you can do the same kind of things, right? Apply and then look at the cluster assignment details here, right? So I hope that was useful. So we're going to continue that next with our feature extraction examples. And then, as Sherry mentioned before, we're going to do an Oracle Data Miner session as well, dedicated with a little more demos and in-depth information that you guys might want to work with. So I think that's it. Sherry, are there any specific questions that people want to see?
No questions.
Okay, great. All right, guys. So thank you very much again for supporting us in this endeavor. And I'm hoping to see you guys back soon in our next sessions. Thank you. Thank you very much, Sherry.